Hello everyone, in this video I'm going to cover a system design question called Design Web Crawler. So let's get started. So remember, the first step in a real system design interview is always by asking some good questions to clarify the scope. Although the scope may seem to be pretty clear, which is just to design a web crawler, you may wonder what questions should I ask. So I would say there's still some room to clarify the scope. So for example, what is the purpose for this web crawler? So the purpose behind this question is to figure out what we are designing for. Because let's take an example. Let's say designing web crawler for search engine is very different from designing a crawler to just crawl the Wikipedia website, or there are some other purpose. So for example, for some research institute, they may want to dig out the structure of the whole web network, which means we don't need to really store the web content. So those different web crawler are very different regarding the scale or the purpose. So let's say the interviewer asks us to design a web crawler for search engine. Which means we are designing a large-scale web crawler, and also we need to store the content. So there are some other questions. So for example, there are, for different websites, although the URL are different, the content may be the same. So what are we going to do with that? So let's say, are we going to dedupe the same content, like the web page with same content but different URL? Let's say we are going to do deduping, because a large percentage of the web pages have duplicate contents. So which means deduping is a very important topic to talk about. Deduping the content. Let's say there might be some other things. So for example, are we designing a web crawler for for videos, for like the pictures? So let's say the non-go. So let's say this is a non-go. So we are not designing a web crawler to download the pictures, like download pictures, and we only care about the HTML for the web page. We don't need to care about like PDF or whatever. So let's say focus on HTML. So until now, I think we have a pretty clear understanding about the scale of the problem and the purpose of the problem, and also some specific feature requests we have defined here. So which means we are designing web crawler for search engine. We need to support content deduping, and we only focus on HTML. So the next step after scoping is to do some constraint analysis. So the constraint analysis usually means you need to think about like the traffic, like collecting some numbers to understand the traffic, the storage we need, like the availability, like the latency, like scalability, something like that. So let's say first of all, let's say the question I want to ask is how many pages are we targeting to download every day? So let's say we are targeting for about 100 million, let's say 100 million pages per day. So each page in average, let's say it is 1 megabytes per page in average. So this gives us, the first number gives us some idea about the traffic. So 100 million per day, which means it is, let me do some calculation. It's 100 million per day, so 24 hours per day and 3,600 seconds. So it is we are targeting about 1K for the QPS. So let's say it is 1K QPS, and let's say the peak time is 2K for the QPS. So this will be a reasonable estimation about the traffic, about the requests we are going to send per second. And also, let's say we have 1 million pages in average, 1 megabytes per page. So 1 megabytes per page means we are targeting for 100. So this is gigabytes, terabytes. It's 100 terabytes. Yeah, 100 TB per day. So let's say for the next 5 years, what will be the space we need? So for 5 years, it is about 2,000 days in total. So 2,000 days, it's 200 TB per 5 year. So now we understand the traffic and the storage. Let's say we are designing some other numbers. Let's say the crawler is going to be highly scalable, and also like I think latency, it really depends on the definition. I wouldn't care about the latency here, too much about the latency here. As long as it is scalable, we can like download 100 million pages per day. And also another thing is the availability. So it should be always available. Availability. So it's not like always available. It's like several nines. So let's say at 99.9 percentage of the availability. So it's like the crawler can be down for like a couple minutes per year, something like that. So having said that, that's mostly about the number for the constraints analysis. Now we understand the scale of the problem, like the traffic we are targeting, the storage we will need. The next step is mostly about doing some high-level design, so which is design overview. So in this section, you propose the general architecture about the whole thing. So here you define the different components you're going to have, and the interactions between the different components, the general data flow, etc. So this one we are not defining some like traditional web service, so we don't have any user actually. So but we still have some services here, but although it's not user targeting, it's not user facing. So usually for a web crawler, you start to have some seed URLs to start with. Then after that, it is something called a URL from I think it's URL frontier, I think. So the URL frontier is mostly to collect the URL and redistribute the URL to assign to different workers, and each worker is so the worker is to receive the URL it is going to download and do the parsing about the HTML. So let's say the worker is going to download the web page, do deduping, and then do parsing to get URLs, and then try to see if the URL has been already crawled or not, etc. And then send it back to the URL frontier. And also it needs to talk about with storage. So the storage part, we will have different storage parts. So like one storage, which is a file system, global file system, you're going to use that for storing the contents of the web page, and the other thing is some DB. We need to design to store some schema. So for example, the URL and the corresponding time. The last time we create this page, and like the hash of the web content. Yeah, etc. So there are two parts. For the storage, we will have the DB part to store the schema of the web pages, and also we have the file system to store the contents of different web page. So having said that, that's a general architecture about the design. So let's see the next part. And by the way, so the URL frontier, it's going to be a service which is about to receive the URL and to push into the queue, and then send the URL to a bunch of the workers, and the workers, before that there would be a load balancer or whatever, but it depends on our design, but overall the worker is not going to be a single worker. It is going to be a bunch of the workers we are going to use for downloading the pages, like do deduping, parsing the HTML, etc. And also for the storage part, we need to think about like the duplication, like the data sharding, although there isn't too much room to think about data sharding, but still, like the data duplication is still a very good topic to talk about in the next part. So the next part, after the design overview, it is about the design details for the different components. So depending on the interviewer's interest, they may lead you to different topics to talk about. So for example, they may ask you about to design some data schema, the DB schema, like what tables and the corresponding column to use, and also the file system, which file system you're going to use, etc. And also they may ask you some general algorithm about the worker, so what it is going to do, what is a workflow, the logic of the worker, etc. to see how much you know about the different parts and understand about the different the design for the different parts in more detail. So let's start with the first one, which is the URL frontier. So the URL frontier, this one, it is going to this is used to, there are two in general, there are two APIs, like insert the URL, and the other thing is to send the request to so this is a service. So the service one is to receive the request to insert, and the other one, it is going to okay, so it's actually not the API to be exposed though. This is one API which is about insertion, but the other one is, it is more like initiating some requests, and so like the two things. One is to insert receive request to insert the coming URLs into queue, and the other one is to send request to workers, including the URLs to download. So this is the two jobs. So for the first one, it is pretty straightforward. It's just about receiving request, inserting the URLs into the queue, but we may need to design the queue a bit more in the next step. And the second one is to send the request to the worker. So it really depends on the priority of the URL we are trying to download. So let's talk about the priority, which is about the queue design. So why we use a queue? So traditionally there are several ways. There are mostly two ways to design about the algorithm for a web crawler, which is DFS or BFS. So if you go with DFS, it could be like the URL can be very deep. So for example, if it is HTTP foo.com and then bar, then bar, then bar, like a lot of bars. So this is going to lead the crawler to a trap, which is not very good. So traditionally, a better way is we use BFS. So for BFS, it is mostly, you know, that BFS is mostly about like a queue, which is a FIFO queue. For BFS, it is like a FIFO queue. So we put the URLs in, and every time we just get the URL that was first inserted into the queue, and then we dump it out and then send to the worker to download the corresponding URL. So that is a better way. Usually, is a better way comparing with DFS, but there are still some other drawbacks. So for example, if you're looking at the Wikipedia page, I would say most of the internal links, most of the URLs in a web page is leading you to other web pages in Wikipedia. So if that is the case, if we don't design the crawler in a good way, it can send a flood of the traffic to the same host. So this could be a potential concern for using BFS, and there could be some other concerns as well. But overall, I would say BFS. Let's say this is BFS concern. But overall, BFS is better comparing to the DFS traditionally. So let's say we are going to use BFS as the underlying, like the basic algorithm we use to prioritize the URL we are going to download. So using BFS, which is a FIFO queue, it's overall good, but it's not that good because like the first one which I talked about is like it is going to send the flood of the traffic to the same host, which is not what we want, because for some website they will have some rate limiter. So for the rate limiter, once we achieve the maximum QPS for the rate limiter, then we are going to get the request errors. So instead of getting succeed code, so we don't want that to happen. So we need to design the queue a bit more. So for the purpose, so for the queue, we need to care several things. So the first one is we don't want to send a lot of traffic to the same host in a short period. So this is the first principle, and also there might be some other principles. For example, let's say for some web pages, let's say it is a very small website people don't care too much about, and there are some other websites. Let's say it is Wikipedia page which has very good knowledge base. So comparing the two websites, we may want to prioritize Wikipedia comparing to another like unknown website. So in that case, we may need to prioritize the web page based on prioritize the URL based on some factors. So for example, like how much of the traffic is received by the corresponding URL every day, whatever, by the same host, etc. So having said that, we may need to design a queue into two parts. The first one is we need to try to prioritize. I mean, if we try to balance the traffic first and then try to prioritize, it may be fine, but it will be easier to try to prioritize the URL first, and then we we try to balance the traffic. So let's say we have a first queue. So the first queue, it is going to, let's separate it into different queues. Let's say Q1, Q2. Let's say this is priority queue. So this is the first queue. So let's say we have a bunch of the queues. So these message queues have different priorities, and we tend to like the number that is smaller tends to have a higher priority. So we tend to consume the messages in like higher priority queue comparing to like the queues with a lower priority. So we are going to, let's say this is subscriber, and then after this subscriber, we have like a nice traffic that is going to prioritize the URLs that has higher priority to be consumed first, and the next priority queue there will be some other queues. So let's say the next queue is more about so let's say how to say that. So it is traffic balance queue. Let's say it is called traffic balance queue. So the traffic balance queue is more, again, we have this Q1 to, let's say, QM. So the traffic balance queue is more about to solve the problem, which is not to send a lot of traffic to the same host in a short period of time. So how do we do that? So what we could do is, so one way we could do is we could bring together like a several hosts, the same hosts into one queue. Let's say Adidas.com and Nike.com is put in Q1, and then for Q2 it is about Wikipedia.com, etc. So we could have each queue to only serve for the traffic for several of the hosts, and then for each queue it is only going to have like several workers. Like for example, for Q1 only worker, so let's say we have Q1 to QM, and we have 2M of the workers. So let's say we are only going to send the message from Q1 to worker 1 and the worker n+1. So in that case, we could, because there is only like 2 workers consuming the same queue, so it is going to serve for the purpose for some rate limiting when we send the traffic to the same host. So that can potentially solve this problem, which is mostly about the URL frontier part we are trying to design. So the queue, so in this part we try to use BFS, and we design the queue a little bit more complex to further have a priority queue and the traffic balance queue to make sure that we care about like the 2 problems we talked about in BFS. So I think that should be pretty much it about the URL frontier part, and the next part is about the worker. So for the worker, it is mostly about sending some HTTP requests to the web to the URL to download the web pages. So the first thing is the DNS. So for DNS, it is from the domain name to the IP address. So what we could do is we could use some cache to cache the relationship from the domain name to the IP address. So this could be one significant improvement when it comes to a large scale web crawler design. So the other thing, so after we get the IP address for the host name, it is for us to download the web pages, and then do some deduping. So the deduping could be very expensive if we compare the original content with all the web pages we have. So what we could do instead, we need to compute a hash for the web content, and instead of comparing the web content, we just compare the hash of the web page content. So that will be like much easier and make the computation more effective. So you may worry about what if there is some conflict about hash value. So that could totally happen, but you know that for a search engine web crawler, we don't need to have like the recall to be 100%. Which means we don't need to download 100% foot percentage of all the web pages. So that's never possible. So instead, if we have like the recall to be like just very high, let's say 80%, that would be a very good number. So the next part, deduping. So for deduping, after we deduping, we need to do HTML parsing to get the URLs from the web page. So this is mostly about some piece of the program to do HTML parsing. A lot of good libraries we could leverage to do this kind of job. And for URL, after we get a bunch of the URLs, we may need to do some URL deduping because maybe we have already crawled the same URL before. Like for example, like a couple minutes ago, whatever. And also we may need to blacklist some URLs we don't want to crawl. So for example, there are some websites that we definitely don't want to include the contents. Then that could be it. So for example, for this step is like for example like disallow list, exclusion, and also URL and the deduping. So for the deduping part, what we could do is so for it, we still leverage like this our storage, which is the database. We are going to talk about it like the database design later on, but it is mostly based on the information in the database, and we need to we shouldn't like query the data from the database every time, but instead we need to have a cache layer sitting on top of it. So every time we just query the URL from the cache to see if it exists or not. And also another thing which may be worth to think about is we may not want to. So for example, for the same URL, we may not really want to download the same page like within download the same page like twice within like a couple minutes, but definitely the web content can change. Because the web content can change, so we definitely need to re-download the web page, like for example after a month or so. So we may need to check the last time we download the web page, and then decide, and then we may have some criteria to decide whether we need to re-download the web page, etc. So like re-download. And then after the URL deduping, it is going to send the request, some RPC request, etc. Let's say just send a request to let's say this is about send the request to URL frontier about the new URL we are going to download, and also we are going to store the web pages and the web pages to the file system, and also we are going to store the URL and also some let's say some schema info to DB. So this is a general logic about a worker. And the next part we may want to talk about is the storage part. So for the storage, it is essentially two parts to think about. One is the file system, and the other one is the DB. So for the file system, we are not expecting you to design like a global file system to store the web pages, but instead what you could do is you could leverage some already existing services on the cloud. For example, like Amazon S3, for example, like the Google storage. Let's say we are going to use Google file system, like the GFS, to store the web pages. And also, let's say we have for the DB, what are we going to use? So we are targeting like 100 million pages per day. Let's say, so then in 10 days, in 2000 days, then it is going to be 2000 days, it is 2000 days, which means 200 billion. Okay, like 200 billion. So for this one, what we could do, essentially we could use, I would prefer to use non-SQL. Although it is okay to use SQL, but for non-SQL, regarding the scalability, it could have some better performance from that perspective. So let's say we are going to design a table. Let's say we use non-SQL for this, and we use big table specifically. And let's say we design the URL for the row key. We are going to use a URL itself, and for the column, let's say what we are going to store. I would say there are several things we need to store, but it's mostly about the schema part, the schema info. So for example, the last download timestamp, and also for example the pass to the storage, etc. And also we may also need to store we may also need to store the hash value, for the web page, etc. So so that's mostly about the storage part. And I remember we also talked about like for the database, for the data storage layer, we also need to have a cache layer sitting up on top of it for easier query for the deduping purpose in the worker, and for both the URL deduping and the content deduping purpose. So for example, for the cache, we could use some memcached to serve for the cache purpose. So until now, I think we have most of the parts explained in the whole system. And other than that, I think it really depends on which way the interviewer is leading you into. So for example, they may ask you about something about monitoring. So I think one thing, for example, one thing about monitoring is we need to monitor the size of the queue. We definitely don't want to have a queue to grow, to keep growing until it is too big to be consumed by several workers. So if a queue is growing too big, and it is okay to send more traffic to the same host, it is not too much currently to send the same host, then we can feel free to add some more workers to consume the same queue for that. And also we may need to monitor how many URLs we currently have, the growth rate, and also for example the freshness of the page, and the total, for example we can also monitor the storage we have used, the CPU, the traffic, etc. So there are quite some signals we could monitor as well. So until now, I think we have pretty much covered most of the system design for this question. So that's it for this video. If you like this video, please help subscribe this channel. I'll see you next time. And if you have any question, please leave some comments below. Thanks for watching. Bye.